All right, welcome to section 13.1 calculator. Okay, so to do an ANOVA, we're going to enter our raw data into list 1, 2, 3. So that's what I did here. So those are our three plot types with the number of plants. After this, let's go over to stat, tests, of course. Hit the up arrow to go all the way down to ANOVA and push enter. And we're going to run an ANOVA on second L1, comma, second L2, comma, and then second L3. There we go. And we get a lot of information here because you figure we have our MST and we have our MSE and we have variability and all of this fun things, all these fun things. But really, our class is just interested in those top two numbers, the F test statistic, and we see that we had a little bit of a rounding error compared to our by hand method. And then we had the p-value right below it. And that's all we're interested in. So we have a lot of information here. Let's not worry about all of this so much because really we're just interested in the test statistic. It's about 7.1, and we're interested in the p-value. So 0.0068, we'll say. Okay, and now the p-value approach is the most straightforward because all we have to do is compare that to alpha. And how does our p-value compare to our alpha, which is 0.05? It's much less. So what does that tell us about our null hypothesis? We are going to reject the null. Okay, so if we reject the null, what kind of evidence do we have? We have sufficient. Whoops. We have sufficient evidence. All right, and then the rest of the conclusion is the same as before. At the alpha equals 0.05 level of significance, to conclude that at least one population mean number of plants is different from the other. So we always conclude the alternative. Okay, so a couple of notes, of course. Since we do have sufficient evidence to conclude that one population mean is different, does our ANOVA test tell us which one? No. So if we were the farmer and we wanted to choose the optimal plot type, we would have to have some more information. So now that we know that one population mean is different, we have to see which one is different. And we can do that quickly by looking at the box plot to see, it says which mean is different, but because we're assuming it's normal, the mean and the median are going to be the same. So let's do that really quick. So as farmers, we can choose the most efficient plot type. So let's go over to stat plot. We're going to turn all of our plots on, and we're going to do box plots on list 1, list 2, list 3. So that one is all set. Oh, sorry. We'll do this one on list 2. Now that one's all set. And then we'll do our final box plot on list 3. There we go. All right, and then finally, we are going to go to a zoom 9 to see our box plots. Okay, so looking at our box plot, which plot outperformed the others? And it was definitely plot 2 or the second population. So that was the spring disc. So if we were farmers, we would want to plot as many plots using a spring disc as possible because they are outperforming the other two. Okay. So carrying on, you guys are going to try one on your own. This example, you guys are going to run a phantoms and go ahead and push pause and then come back and see how you did. All right, welcome back. So here's our solution. We're testing 3 population means. So we have our hypothesis test. It's always set up the same. Our assumptions are a little bit trickier. We check for the sample standard deviation using a 1-var stats for each of our populations. So we put the first population in list 1, or the first sample, second sample in list 2, third sample in list 3, 1-var stats 3 times to get these 3 things. And then we choose the largest and make sure it's less than twice the smallest. And it is, so we're good to go. We run an ANOVA on list 1, list 2, and list 3, and we get our F test statistic and our p-value, and our p-value is less than the alpha, which is 0.05. So again, we reject the null. So we have sufficient evidence at that level of significance to conclude the alternative. At least one mean reading score for one of the methods is different on the post-treatment comprehension plan. All right, lovely. And then just some reflection on these questions, or this ANOVA test. Go ahead on your own, see how you're going to interpret it.